All right, take a look at this GeoGebra exploration about dilations. So we're moving here into the non-rigid motion world here, where we're starting to change the size of the shape through a dilation factor. You can see here it defaults to scale factor 3. Think about what that means. If a scale factor is 3, because it says factor, that should be an indication to you that it's going to be 3 times bigger, okay? So what does that mean? Think about the implications for angle measures. If the angle measures change, does it look like they change? Think about that. Think about the side lengths. For example, compare BC to EF. Compare the lengths of those segments. Consider that relationship. Now, what if I change the scale factor to something like 0.5? Could I do that? Sure can. Yeah, that's going to make this figure a lot smaller. Look how much smaller it got. Now it's half the size of the pre-image, which is orange. The image, which is purple, is now half the size. I'm going to put it back to 3 for the time being. I want to click these check boxes over here. Show dilation rays. That's interesting. Look at that. When you connect the image and the pre-image, or of the corresponding points, those rays intersect at what we call the center of rotation. Excuse me, not the center of rotation, the center of dilation, which is 0.0 in this case. Now look what happens when I move 0.0. Let me see if I can move this. Traditionally, the center of dilation is the origin. So that's what it looks like when the center of dilation is the origin. And when the center of dilation is the origin, if you click these additional boxes, I want you to consider the relationship here between these coordinates. So between, for example, F and C, which are corresponding points. 20, 10, and 60, 30. Think about the scale factor between 20 to 60 and 10 to 30. Think about that scale factor, compare it to the scale factor listed over here, okay? So consider that. Also, consider if this coordinate pair relationship, this ordered pair relationship with the scale factor, exists when the center of dilation is not the origin. So if I move the center of dilation to somewhere besides the origin, let's see what happens. Does that multiplicative relationship still exist between the image and the pre-image? Think about that, okay? Last thing I want to point out is the distances between the center of dilation and the pre-image, and the distance between the center of dilation and the image. What I mean by that is this. Compare this distance right here. I'm going to use the line tool. Hang on. There we go. Compare this distance right here to this distance right here. Okay. And think about how many times larger the second segment is there, OE, than OB. Okay. You could also consider the distance between OB and BE. Okay, there's a ratio there. You could think of it as, in this case, 3 parts, right? Scale factor is 3. Think about how many parts OB represents compared to BE. All right, so that should more than get you started in thinking about dilations and answering some of the questions on the paper that I provided. So, as always, if you need anything, you always know how to reach me. So good luck on the exploration. Looking forward to seeing you in class and catching up more on this topic. Have a good one.